Here we go. First thing, you need to address each of the following. And for JV and Charles, this is the Chapter 2 quiz. It went super poorly. We're going to get another shot tonight. You may wind up watching this video this evening while you're working the quiz. That's okay. It's open note. As long as you're doing it and it's not AI or a friend and you're just copying the answers, I'm cool with it. All right. So here we go. On number 1, we are supposed to write, and there were 2 problems here before, so that's my bad. We need to write this in standard form. Then we need to identify the vertex, the axis of symmetry, and the x-intercepts or the roots of this graph. Okay. Right off the bat, if we want standard form, I know that it's going to look like that x minus h stuff that's written here. And I gave you guys the formula just in case, but let's dig into that even more specifically. Right off the bat, if I want to write this thing in standard form, what is the coefficient connected inside the parentheses to the x? What do you think, Huggins? What number is connected to this x right here, inside the parentheses?
2.
So the 2 is...
I don't know, 16.
So don't guess. Just literally forget about this a part. What's the number in front of this x?
A.
How about inside the parentheses? If I write x, it's how many x?
I'm 0 for 3, I think.
Do you agree with this? There's a 1 there that we just don't write. Okay, that's all I was asking. I need it to be a 1. Now, unfortunately, in our problem, what is connected to it? A 2. So I'm going to factor out a 2 from 1, 2, or 3 of those terms there. And if you need to check your notes, you can. Riley says 2. I'm going to factor a 2 out of just the x terms. 100%. So let's do that. This one, if I do this, I'll take a 2 out. What remains inside of these parentheses? X squared plus 8x. I'm going to leave an incredibly large, awkward gap right there and say plus 20. Now, when we're doing this, the formal process, the work that we're actually completing right now, we are doing what's called completing the square because we're going to make a perfect square trinomial so that it factors as x minus h squared. Now, off the top of your head or your note card or your notes, what number can I add here that doesn't really change it? A 0. Now, there's infinitely many ways you could write 0. Plus 1, minus 1, plus 2, minus 2, so forth and so on. How do I decide which of those infinitely many choices I want to go with? Good. Take this number, 8, we divide it by 2, and we do what? We square it. This is the square part of our perfect square. Now, 8 divided by 2 is, careful, it's 4 first. And then we square it and we get 16. Now, 3 statements that I'm going to claim are really true in this situation. I've added 0. Do you guys agree? Okay? I could also say I've added and subtracted 16. Here's the last one. I can also claim I've added and subtracted 32. How would I make that claim? How am I able, and I'll tell you it's true. If I say I really added and subtracted 32, how on earth does that work? Because there's a 2 connected to everything in those parentheses. Okay, one of these things I don't want inside. The positive is cool or the negative is cool. Which one do I want to get rid of? I want to keep the positive. I want to get rid of the negative. Unfortunately, everything in those parentheses is stuck by multiplying by 2, right? So if you want to take something out of it, you actually have to do that operation. I'm not going to switch back and forth between colors anymore on this. Okay, I'm going to distribute this to just the negative 1. So let's see what we get. 2, and then we get x squared plus 8x plus 16. And when you distribute the 2 to this, what comes out? A negative 32 and a plus 20. The plus 20 was already there. The negative 32 is just 2 times negative 16. Have I lost anybody yet? Okay. This is special. if we look at this, and it's going to happen every single time, if we don't know the shortcut for perfect square trinomials, it's okay because we're going to get to it with grouping or shortcut. Is the leading coefficient 1? And 1 times 16, and this is a shortcut, is 16. Can you find me two numbers that multiply to be 16 but add up to 8? 2 and 8 won't work. Those add up to 10. 4 and 4. So if I use my shortcut, it'd be x plus 4 times x plus 4. Do you guys agree with that? But there's a better way to write that. Instead of writing x plus 4 times x plus 4, it's just x plus 4 squared. When I combine the terms on the outside, what am I left with? Minus 12. And I hate that too, so we're going to fix it. All right. Am I in this form at this point? Boom. There's a 1 point, just so you know. If you got here, you got a point. Okay, the other part. Done. Standard form. Knocked out. What's the vertex? In this form, which letters represent the vertex? In my actual true standard form that's up above. HK. Now, here's where this is weird. X minus what? What do I have to subtract so it changes to a plus 4? My vertex is negative 4 for the x value. And what about the k value? Negative 12. There's the vertex. Okay, that was a point. If I write AOS, and I'm sure you have this one time in your notes, axis of symmetry, every parabola looks like this. Every parabola is symmetric about some line that runs through it. Now it just so happens that that vertical line passes right through which point? The vertex. If you take a parabola and fold it over itself, it's going to happen at the vertex. Can you guys tell me the x-coordinate of the vertex? Oh, okay. The axis of symmetry is x equals negative 4. It's a vertical line right there. The last one are the roots, or zeros or x-intercepts. X-ints. Okay. This one might be a little bit more challenging, and there's a few different ways you can do it. If I want to find the x-intercepts, I'm going to plug what in for y? Or for f of x in this case. It's 0, right? Check it out. When I looked at everybody's work, and I don't think we did this, but maybe this is an easier way. You could set this equal to 0, right? Is this the same thing, just written differently? So, I love the idea of practicing with factoring, but let's try this real quick. These are all equivalent, every single one of them, because I've just added 0. I'm going to try setting this equal to 0 and see if it's easier for everybody. So let's try that. If I work through this, and I want you guys to try this, on this side, let's put this most simplified form and set it equal to 0. And I'm going to give you guys a second. I want to see what your mathematics leads you to. While you're doing it, I will do it the quadratic formula way. If I'm trying to solve this thing for x, and remember, we're doing this as instead of the quadratic formula. I'll erase it and we'll look at the quadratic formula here in a minute. If you want to solve that expression, that equation for x, what's the first thing you would do? Everybody add 12 first. Now, in one line, if I've added 12, can I also divide by 2? So I could have gotten 12, and I'll just do it all. X plus 4 squared. Everybody cool with that? Okay, what would I divide both sides by? Okay, so I get 6 equals x plus 4 squared. Are you all still on the same page? And I'm going to let people catch up. What would I do next? I'm going to take the square root. I'll do the right side of this. The square root is x plus 4. How about the left side? Love it. Plus or minus the square root of 6.
Why do you, this might be obvious, but why do you get rid of 2 and it became 6?
So I divided both sides by 2.
Oh, yeah.
Yep. Divide by 2. Square root. And this was add 12. All right. One step away. To solve for x, what would you do? Now, I'm going to do it more in a different order. I'm just going to say it's negative 4 plus or minus the square root of 6. And we can solve it. We can solve it here like this. Alternatively, if you didn't notice this, and I don't know that anybody did it, but it is a nice kind of trick to have up your sleeve, that might feel fairly natural to people. It is possible and likely that you didn't notice that. Give it a second. I'm going to erase this. I'm just going to show you the quadratic formula. I'll just do it in red down here. Okay. Quadratic formula, if I were doing this right off the bat before I plug it in, before anything else, what's the first thing we check with factoring? GCF every time. Is there anything that goes into all these? So the step that I normally don't show, if I do this, and I just set the original equal to 0, which is what most people did, I'm going to divide both sides by 2. And I'm just dividing by the GCF. Are you guys cool with what I've done there just to make my numbers smaller? GCF and then I divided both sides. Okay, it's going to be ugly like format-wise. But let's see, x equals, we have ax squared and bx in c. What is negative b? Negative 8 plus or minus the square root of what's b squared? 8 squared, and that is 64 minus 4 times a times c, right? And all of that gets divided by what? 2a. And in the simplified version, that's just 2. Okay. I hate the way that this is shaken out everywhere else. I'm going to just continue working here and we'll just erase it. All right. If you got here, we're on a good kind of start. Let's see. That equals negative 8 plus or minus the square root of, what's 64 minus 40? 24. I'm not going to write 24. Can you guys think of a square number that goes into 24? Give me 2 numbers to multiply to be 24, and your 6 and 4 will do it. Are either of those square? 4 is a square number. Let's back up one step. Do you guys understand? Because I use that language like regularly. Do you know what I mean by square number? Something multiplied by itself, right? Yeah. Something that easy square root. Okay. In my head, I'm already thinking that this is really 4 times 6. And that's still all over 2, right? Why would I spend the time to think it's 4 times 6? What is the square root of this 4? Now, instead of writing everything over 2, because I know how fractions work, I can just split it up like this. We're one step away at this point. What's negative 8 over 2? Negative 4. And what happens with this 2 right here and this 2 right here? They gone. So it's plus or minus the square root of what number? Check it out. Same. Whether you do the quadratic formula, which is awesome if you like the quadratic formula, or you recognize that we have an equivalent form right here and just set it equal to 0, we get 2x intercepts. And I'm just going to write it as a single point. It's negative 4 plus or minus the square root of 6, comma 0. Full disclosure, love this answer. Despise negative 1.55 and negative 6 point whatever. Okay, exact answers are always easier unless it's a very specific context with like real world stuff. Okay, mistakes here. Spend a minute, look over your page, compare with what we just did, compare to your original, find your mistakes. I'm going to call like 3 random people. I want to know your mistakes. All right, here's number 2. Looking at this, couple things. On the test, on your take-home quiz, I changed the order because it feels weird to have positive first, and I didn't realize that initially. Without this language, if we look at this function, positive or negative leading coefficient? Okay, exponent or degree, even or odd number? So give me the easiest odd number. 3 is bigger than the easiest. 1. Show me what y equals 1x looks like, just with your hands. Like that. Down to the left, up to the right. Do you guys agree? Okay, if you had given me this, I'm okay with it. Now check it out. As x goes to infinity, This statement right here, does this mean goes to the right or goes to the left? If x goes to infinity. That goes to the right. What do we say it does to the right? It goes up. I would take this answer. I'm cool with that. Or preferred and more formal, I would take infinity. It goes up forever. How about this one? As x goes to negative infinity, does that mean I'm going left or right? Left. And what happens to my graph based on our leading coefficient test as I go left? It goes downward forever, which give me a, it's not a number, but give me a almost number. Negative infinity. Cool. All right. I was after either the lemniscate, that's the actual name of that figure 8 shape that is infinity, a lemniscate, or the arrows I'm fine with. You should not give me two different ones on the same end behavior, though, just so you're aware. Like, your answer was good, and I think I gave you credit for it. I don't recall. I think I did. Be careful. Okay. All right. Find the real zeros. Anytime we're solving zeros, we do what first? Every single time. Well, yeah. What do we start factoring, though? Greatest common factor. What goes into both of those numbers? A 2? Anything else? X squared. I'm going to factor out a 2x squared. What does it leave behind? All right. Can you factor either of these any further? This is the whole factorization. This is it. Now, check it out. This root, if I'm looking at these, I'm going to write the roots, and I'll do them repetitive. How many times did this x show up as a factor? Twice. Which means what value of x would you pick to make this factor equal to 0? 0, and it showed up twice. I'm going to write it twice. You don't have to. What value of x makes this other factor 0? -2. All right. I did not count people wrong for this one if you didn't use your number line, unless the graph that you gave me doesn't agree with your answer to part B. If you gave me roots that don't align with the graph you draw, I did not give you credit. So, I want us to get in the habit of making this number line because it becomes super duper helpful. Here's a function f of x that we're considering. I only need to put two numbers on here. What are they? 0 and -2. So check it out. I know that at this root, at x equals 0, it touch and turns. And it's touch and turn around, but that's wordy. What happens at this root? We cross. All right. I don't care about the actual numbers. Maybe I should just not have given you any numbers on the y-axis. I have split the real numbers on this number line into 3 equal intervals, which maybe you don't think they're equal, but it's weird they are. I can pick something in the left, the middle, or the right interval. What's the easiest possible number to plug in? I'm going to pick a 1. Which interval is that in? Left, mid, or right? Are you sure? 1's not between -2 and 0, unless you meant this one. Yeah, it's over here. All right, so check it. I talked about this when we went through it in class, but I don't know if it stuck, and this is going to be helpful. Tried to change color, didn't work. When I plug in a 1, there are two places I can do it. I could plug in a 1 here. And let's just check it out real quick. 2 times 1 is 2, plus 4 times 1 is 4. It's 6. Do you guys agree with that? Okay, I got a 6. But check it out. This factored form, it's equivalent. It just looks different. 2 times 1 is 2. And I just plugged a 1 in for this x. What if you plug a 1 in here? What's inside the parentheses? 3, and 2 times 3 is still... We get the same answer. It's easier to evaluate oftentimes by plugging in here. I don't really care that it's a 6. All I care about is that it was what sign? Positive. At 0, it's going to touch, and then it's going to turn back around, which means it's still positive. And over here it's... All right. I'm going to put my roots on here. Here's 0. Here's -2. I know it goes down to the left forever, and then it comes up to -2 and crosses, I'm sorry. So we'll do that. Don't know how tall it gets, doesn't matter. It does what at this x-intercept? Touches and then turns back around. That's a good sketch. It's not a perfect graph, but it's a good sketch. Now, realistically, we know that at 1, we already decided it should be way up here, like it's way steeper than I've drawn it. But that's okay. This is a sketch. Questions from this one?
Again, this might be obvious, but I just don't understand how you get the 2 zeros for the roots.
So if we wrote this out, do you agree, and great question, do you agree that if we wrote this out, I could write this as x, and let's keep the 2 there, 2 times x times x times x plus 2. Like that's literally what x squared means. So when I do it like this, there's 1 factor, 2 factor, 3 factors. Now the 2, if you want it, we could say 2x is a factor. Okay, if you set 2x equal to 0, what do you get for x? Okay, if you set this x equal to 0, what do you get for x? And that's always a weird question because it's just that. And this one, x plus 2 equal to 0.
-2.
There's our 3 roots.
Okay.
Cool. When it shows up like this, and in your notes you're going to say x minus k to the n or something like that, where n is the number of times it shows up.
Don't erase that real quick.
Okay.
Don't erase that.
And I'll actually just post this on the Google Classroom after class. Okay. All right. So point-wise, if you guys are just dying to know, this front page was worth 10. There were 4 points for the first one, 2 points on A, 2 points on B, which I required that you factored it and then told me the zeros. And then I was really nice, I won't be tonight. 2 points here. Did you use a number line? Because I want to see this because I promise it's going to be useful. And then does your graph agree with the number line and the other information? Cool. Factoring is really easy if you always check GCF first. Did you just dab? Cool. All right. Couple things. Notice this. I asked you to use long division, and then there's something else that it says. If you did the long division and still got -1 and you're wondering why, there's a follow-up. Is it a factor? And there was weird language here. Okay. Looking at it. My divisor is 5x minus 3. The dividend is 30x squared minus 3x plus 8. Okay. I need to get a 30x squared here. What's the most important part of my divisor? 5x. Sean, if you're falling asleep, this will help because I think your answer was wonky here. Like, not throwing shade, but you should pay attention. Now, I want to make sure that I get to a 30x squared right here. And then it looks like minus 18x. Somebody multiplied by -6, and I totally get it because you're trying to get the 30x squared to fall out. But with division, what happens as soon as I write this number here? We subtract it, and now it falls out. Okay, here's a common mistake. What's -3 minus -18? Also known as -3 plus 18. 15x plus 8. Okay, what do I multiply 5x by to get to 15x? 3. I get 15x minus 9. I'll subtract it. The x's are gone. What's 8 minus -9? 17. Okay, so the weird answers that I got here. Somebody said, yes, it's a factor, the remainder is 0, and you had the division correct. What was the remainder? 17 is the remainder. So, if you stopped here, I'm okay with it. This is the correct quotient, 6x plus 3. Is it a factor? How do you know it's not a factor? No. R of x, which is just what we used in class for remainder, is equal to 17. Or more specifically, all I care about is it's not 0. All right. This one was worth 3 points. Did you try it? So everybody should got 1 point. Did you get the right quotient and remainder? And did you say, no, it's not a factor? Cool. Nice. All right. Find the remaining factors. If this is indeed a factor, what should my remainder be? 0. So let's check. What goes on the outside if I'm doing this synthetically? -6. And then check it out. In my head, I'm thinking 3, 2, 1, even though we don't write it, and 0, even though we don't write it. Am I missing any powers? Oh, we are clear for takeoff. So let's see, we get 2, 11, negative 21, and negative 90. It better come out to be a 0. And I'm going kind of quick. I want to make sure we have time to get everything. But I think we started at like noon, or maybe 11:55. We've only been working for 20 minutes. Doesn't feel insanely fast to me. Probably kind of fast to some of you guys, but totally reasonable to do this, I think, and I hope, in a class period. If it wasn't yesterday, it will be tonight. All right, how do I do this? I multiply. What's negative 6 times 2? Negative 12. We add them. 11 minus 12, or negative 12 plus 11. Negative 1 times 6. Moment of truth here. Negative 21 plus 6. Negative 15. That will be a positive 90, and I like to do this. Okay, what did we just determine? It is a factor. Now, most of you have a note. 2 words is all the note that I had. What's my note say? Not goon.
Others 1. Others over 1. Whatever that says. I don't know what that means.
I said others, and then I stopped writing because I got distracted. Okay, most of it says go on. I want to be really clear with the writing and the way that we like clarify stuff. Right now, what we have just decided is that this function f of x, we already know one of its factors. What did we just verify was indeed a factor? Careful, that's a root. X plus 6 was one factor. Can you tell me the other factor? 2, because we're just going to use these as our coefficients. X squared minus x minus 15. If you stopped here, you got that lovely go on comment from me. Question, Riley. Okay. I'm going to pretend that you asked one, and I'm going to answer something that I think is a reasonable question here. Somebody's probably looking at this saying, why are we multiplying this? If I said, what are the factors of 12? Can you give me 2 of them? 4 and 3, I think, but I'll take it because you were probably thinking 2 and 6. If I claim that 3 and 4 are factors of 12, do you guys agree? Yeah. Which means I could write 12 as 3 times 4, right? Things can be expressed as the product of their factors. That's what factoring is doing. Now, as I look at this, can you factor this one any further? I don't know how. It's just x plus 6. This one, though, can you factor it? Maybe, right? Let's check it. I'm going to run through the list. And I'm going to do some scratch work just so I can write my single answer nicely. I want to check if this factors any further. Because notice, to find the remaining factors. Okay, if you stopped here, you've only found 1. I'm more clear with the language on the second version. Okay, I need to try to factor this thing. 2x squared minus x minus 15. And I'm just going to do it here so it looks nicer. Is there a GCF? Shucks. Is the leading coefficient 1? Double shucks. Can you guys think of factors of negative 30 that add up to a negative 1? Ooh. It's negative 6 and 5. Okay. Somebody, I don't remember who, not that I would call you out anyway. I want you guys to tell me what's wrong. Somebody did this, and they went, oh yeah, x minus 6, x plus 5. What did they do wrong? Can you be louder? So 1, you left out the 2. That's part of the issue, but I'm going to say there's a bigger issue. You've tried to use the shortcut when the leading coefficient was 2. It wasn't 1. We can't use the shortcut, which means we get to use this lovely idea of grouping where we write a 3-nomial with how many terms instead? We're going to use these magic numbers to replace this guy, right? We're going to write it with 4 terms so we can group them. Okay, so let's do that. 2x squared minus 6x plus 5x minus 15. Where, again, this part, negative 6x plus 5x, is just a different way to write that term. All right, parentheses around both, keeping the addition sign between. What goes into the first group? GCF of that first group. And I'll let everybody catch up. a 2, and an x. If I factor a 2x out of this one, what does it leave behind? X minus what? 3. Okay, what's the GCF here on the second group? So it's a plus 5. And what does it leave behind? That's what I need to happen. I can see my other two factors. So I'm going to come back over here then. I'm going to let x plus 6 come along for the ride. What was another one of my factors we just discovered? 2x plus 5. The front pieces. And one more factor? X minus 3. I have now confirmed that this was a factor, and furthermore, I've used the result of my division to find the other factors. There was one similar to this. I don't think it's the exact same one, but there was a couple of these similar to this on your homework. Because I remember I gave you 2 factors and you had to go 2 steps deep. Okay. We done. How many factors did we just find on this cubic? 3. Interesting. Okay. If you had to find the roots, you could, but we were just asked to factor. Cool. There were 2 points here. Did you do synthetic division and verify it? And then did you find me the other factors? Cool. All right. Lots of real ugly work going on here. Don't. I'm just going to start counting. 6. How many x to the 5th? 0 of them. How many? There's 4 or 3 of the. Oh my gosh. I'm going to put a 3 right here, and I'm just going to talk through it as I'm writing. Okay. 2x to the 6th. 0x to the 5th. How many x to the 4th? How many x to the 3rds? How many x squareds? How many x's? How many constants? Or x to the 0s, if you will. Okay. Let's check it out. Like it's hot. Okay. 3 times 2. Plus 0. Times 3. Oh, hold on. I heard, is it what?
It's not 15.
At the end?
For the 58, negative 58, 60.
Nope, that's 5. What's 63 minus 58?
The 3 isn't on the outside. Is it minus?
Nope. No. Because f of 3,
It's already
yep, we're already there. Because if you look at your notes, the remainder theorem says the remainder when you divide by x minus k. And if we're doing that with synthetic division, we just put k. All right, 3 times 15 is? All right, here's where somebody got all goofy with it. And I don't know what happened. I think I just took off a half for a little math mistake. What's 3 times 40? What's 3 times 5? Those add up to 135. Okay, do I need to have x to the 5th plus 6x to the 4th plus 21x cubed, blah, 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 blah? All I care about when we use the remainder theorem is the remainder. We have just determined that because of this, therefore, via the remainder theorem, f of 3 is what? For those of you that did 3 to the 6th and you wrote it all out, gross. It works and it's okay. Don't do it like that. Cool. This is super fast. It might be faster if we don't talk through it. It might be faster than typing it into your calculator, like legitimately. I don't know how good you guys are at calculators. All right. 2 points here. Did you try it, is what I wound up doing, and did you get 136? All right. Last one. What number am I allowed to multiply? There's no equation, so I can't even think about doing something to both sides. What can I multiply this by that doesn't change it? 1. And just like we saw earlier with 0, there's like a ton of ways to do it. If only I knew that there was a number that would allow me to multiply this by it in the denominator and turn it into an only real number. Can you imagine? Oh, my conjugate. What's the conjugate of 4 minus 5i? Okay, somebody's going to have a big moment here in this. I don't know the word for that. I don't know if there's a word. What has to go in the numerator? Because we're multiplying by 1. You can't put a 1 up here. It has to be the same in the numerator and denominator. Okay. Now, this problem should be crazy fast. I think it's only one step. This is 2 times 4 is 8 plus 10i. Are you guys cool with that? Okay, and it's really going to be 2 steps because I'm going to take a little one. Anytime I'm multiplying a number by its conjugate, a plus bi times a minus bi. Is there a shortcut that we talked about? The il falls out, right? The inside, no, hold on. The oi falls out. The outsides and the insides. Which means you wind up getting just this, a squared, minus a b squared I squared, which is just plus b squared. What's a in this case? 4, so 4 squared is 16. What's b? 5 squared is? So take 25, let's add 16, but in my head I go 25 plus 10 is 35. Add 6 more. Because I know that this is always going to be equal if you multiply by its conjugate. It's just this. And all that I've done is I said, hey, what's 4 squared plus 5 squared? Which winds up being 16 plus 25. Okay, I didn't count you wrong, but this is not really and truly in standard form yet. One more step. I need to be very easily and clearly able to identify A and B if it's a number in complex form. If I have a fraction like this, can I split a numerator if it's over the same denominator? Yes, I can. Not a lot of confidence in those glazes or glances. 8 41sts plus 10 41sts I. It's ugly and it sucks to do it, but do it. All right. So talking through everything in detail took us 37 minutes. My thought, and like if you disagree, let me know. My thought is that you should be able to work faster independently than us working as a whole group and writing everything and showing every single step along the way.
If we get a question wrong, is it like, are you grading it like a quiz?
I am going to grade it like a quiz.